Hello everybody! Today I'm going to show you how to draw the Lewis dot diagram and the VESPR, or the valence shell electron pair diagram for xenon dioxydifluoride, which is this lovely molecule right here. Shall we? So xenon has how many electrons? Let's figure it out. Xenon has 34 electrons, 8 coming from xenon, plus 12 from the oxygen, and 14, ooh, it's a horrible 7, 14 from the fluorine. In total, we have 34 electrons. This will help us determine how to draw the Lewis dot diagram. Keep in mind, we need to fill it with 34 electrons. Again, xenon would be our central atom. I'll start off by drawing 4 bonds. At the top we have fluorine, bottom we have fluorine, to the left we have oxygen, to the right we have oxygen. I can start in by filling each shell. So now we filled in 16, we have 18 remaining. So 2, 4, 6, 8, 2, 4, 6, 8. Now, when you count this, you realize it's only 32, and that really doesn't make any sense because we need 34. So in order to do so, oxygen is going to do something wacky and form double bonds. So oxygen is going to form double bonds with xenon, and it's only going to have 2, 4 electrons. And this doesn't really solve our problems because we still have 32 electrons. Now, if you remember, xenon can break the octet rule, so it's going to have 2 lone pairs right here. The importance of drawing a Lewis dot diagram is that it shows us how many electron pairs we have. So we have 1, 2, 3, 4, and 5. We have 5 electron pairs. Now, Lewis diagrams are efficient that way, that it shows us how many electron pairs it does have, but one thing it fails to do is show us how it looks like in reality, so the 3-dimensional shape. And that can be a little struggle sometimes. So according to the VESPR diagram, if we draw it, let's try to keep this right here so you can keep this as a reference. So xenon here would still be the central atom. And we can have its lone pairs right here. And it will still form double bonds. I'll tell you why it's slightly curved. And then we use special shapes to show how molecules or atoms look like. So we use these broken lines to show that an atom is on the page. And then we use this wedge or triangle looking shape to show that the atom is coming out of the page. This shape, this 5 electron group shape with one lone pair, is called a seesaw. Now it's really hard to see why it's a seesaw because it's still a 2-dimensional figure and it's really hard to visualize. So a 3D, which I am about to show you right now. In this 3D model, we have it looking like this. Let me pull up another Lewis dot diagram so we can compare both of them. There you go. There you go. So if we compare these two, this one right here is clearly a Lewis diagram because it shows a 2-dimensional figure. The one to your left, however, is the VESPR molecule diagram, or the actual shape per se. The white ones here are oxygen. The green ones are the fluorine, and the one without an atom is the lone pair. Now, the shape of this looks like the way it is because, as I mentioned, it has lone pairs. What lone pairs do is they have repulsion forces. We need to remember that the lone pair, the lone pair bonding is greater than the lone pair bonding pair and the bonding pair. So the lone pair bonding has the greatest repulsion forces. And because of that, what happens is all the other atoms get slightly pushed together. So when these get pushed together, the fluorine and the oxygen form an angle that is less than 90 degrees. The fluorine and the other fluorine form a bonding angle of less than 120 degrees. And if we draw our VESPR diagram again, you can see how it's slightly like a seesaw, with the oxygen being the base and then the fluorine being the little seesaw that goes up and down. And that is how you draw the Lewis and the VESPR diagram for xenon dioxide difluoride. Thank you for watching.